Hi, my name is Jordan,
And I am on.
and this is our bridge project. Our bridge was required to be as light as possible while also having a clear span of 600 millimeters underneath it while supporting 10 kilograms of weight for at least 10 seconds. Our bridge is modelled off of a truss bridge, like one you might see on railways. This is because this type of bridge is known to be very strong, relatively simple, and require little materials. We started out building our bridge by just simply gluing various sticks together in an offset pattern in order to create one long sturdy piece that we would use for the bottom deck. We then repeated this process to create the opposite side piece. These two pieces were to be 800 millimeters long. This was to ensure that the bridge would be long enough to have a clear span of 600 millimeters, while also having enough room to have the bridge propped up on either side of the 600 millimeter gap. We used the weights that would later be used to load the bridge to lay on top of the popsicle sticks while the glue was drying. This ensured that there would be no gaps of air in the glue while it was drying, giving us the best possible final result. We then moved on to connecting these two pieces while simultaneously creating the top deck, where the load would be placed. In order to create the top deck, we used many side-by-side popsicle sticks, with other popsicle sticks lining the underside perpendicular to these sticks. These ensured that none of the sticks could slide around while the load was being applied. It also gave the top deck a lot more rigidity. Once the top and bottom decks had been completed, we then moved on to putting them together. Now, this was certainly the most difficult part of building the bridge, as it was very intricate and fiddly and required a lot of patience while waiting for the glue to dry. This part of building the bridge would have taken up 2/3 of the entire time we were building the bridge. Our first attempt at building the bridge carried mixed results. While technically the bridge did in fact support the weight for the required amount of time, and with the appropriate clear span, it did however show significant deformation and forced us to reevaluate the situation. We realised that many of the members that were supposed to connect the top and bottom decks were in fact not properly bonded to the bottom deck. This meant that they were not taking any of the load at all and were thus causing the bridge to bend, as the weight was being taken by only the top deck and it could not pass on the forces to the bottom deck. With this in mind, we then, for our second attempt, glued all of the problem members and then left the bridge to dry overnight before placing any load on it. This worked a treat, and there was very little deformation at all in our second attempt, and we believed that our bridge could easily hold upwards of 30 kilos. Reflecting on our project, it is clear that while we definitely could have been more patient with regard to letting the glue dry for a longer amount of time before testing the bridge under the required conditions, every other aspect of the project was done to a very high standard. We put a lot of thought and trial and error into our bridge, and our final project exceeds our expectations. We do, however, believe that we could have reduced the thickness of the bottom deck in order to reduce the weight of the bridge. Thank you for listening.